So, to me, I hope that answered your question. Our next question is from Stephen. Okay? So, Stephen, thank you very much for sending this question, and it's really a nice question. And it says, okay, let me just get a color that we can see on the white. Lizards of a certain species on an island are usually brown in color. Okay? Now, the minute we see lizards and we see an island, we immediately know that we are looking at selection, we're looking at variation. Okay? Those are the things that we're going to be looking at in this question. So, brown in color. A mutation is in one gene of body color results in red or black lizards. Okay? Black lizards, why are they good or bad? They camouflage well against the dark rocks. They warm up faster because, as you know, dark colors absorb light easier. White colors reflect light, or lighter colors will reflect and warm colors will absorb on cold days. This gives them the energy to avoid predators. Okay, so scientists, now remember, this here is the statement. All right, so scientists investigated the relationship between what? The color of lizards in a population and the survival rate on the island. So the color versus survival rate. Immediately, you know, and I have told you many times, you look at that statement. If you change the wording to say, to investigate, look, to investigate the relationship between the color of lizards, that would be your aim. Because an aim always has two blah, 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 blah. That's the aim. Okay? This here is just the statement. But in the statement, we can pick up that this is the independent variable. And survival rate is going to be the dependent variable. Remember your dependent variable, DROMI. Your dependent or resulting variable, let me write this down. Look here, DROMY. The dependent or resulting variable that is observed or measured, okay, and is shown on the x-axis. Okay, so this DROMI is going to be your dependent variable. It is the resulting variable. So your resulting variable is always going to be your dependent or resulting variable. Alrighty, now they conducted the investigation as follows. They selected a group of lizards of a certain species. So they are all from the same species, and if they're from the same species, we are talking to the validity of the experiment, which is good. They recorded the percentage of each color in the selected group. They repeated the investigation. Now, repeating that investigation over a period of 30 generations means that this, as well as that, talks to the fact that the results are reliable. So it talks to the reliability. This talks to the validity. Okay, so reliable because they did it over a long period of time and they repeated it often. Okay. So it says here, the results of the investigation have shown. So the color of the lizards, this is our independent variable, and the percentage of the color in the population that survived, well, this is going to be, obviously they survived because you can see they survived. This is going to be your dependent variable. Okay, so it says use the theory of natural selection to explain the higher percentage of black lizards in a population over 30 generations. All right, now, let's first look at what a population is. okay? Because we're looking at natural selection, guys. So, and why the black lizards were the ones that survived. Okay, so the first thing is going to be, I want you to look at this. Your sources of variation. Okay, this is NB. Learn well. Okay. So your sources of variation, they can ask you in so many different ways. And the reason I'm going over sources of variation is here in the question, they say that a mutation, all right, is what caused this change in the skin color. So it's a source of variation, and that's why I'm going to go through this with you first. This you would need to know. Remember, CMRR. Okay? So CMRRR or CMRRR. The C is for crossing over during prophase 1 in meiosis. Okay? The M is for mutations. Mutations cause variation. Crossing over causes variation, so mutations. The third, we now start with our R's, and our R's are random, random, and random. But random what? The first random is going to be random assortment of chromosomes metaphase 1 and 2. All right. It's when those chromosomes align at the equator and you don't know which chromosome is going to go to which pole. And then when you have, so you've got during metaphase 1, you've got your double row of chromosomes, and in metaphase 2, you've got your single chromosomes, and they're going to pull apart. All right, your individual chromosomes. Now, the second random is going to be random mating. So the female will mate with this male, then next time she mates with another male. So it's random mating. And the last random is going to be random fertilization. So which sperm is going to get to the ovum to fertilize that little ovum? Okay, and remember, out of the 4 gametes in the female, 1 becomes the ovum. It could be anyone that becomes the ovum, but 1 becomes the ovum, the other 3 are the polar bodies that just simply get absorbed. Right, and in your males, well, you've got millions of little sperm cells that float around. Okay, so those are your sources of variation. The next point before we go on that you must know for this is population. So what is a population? And a population, okay, what is a population? It's individuals of different ages okay, that, and this is important, belong to the same species, okay, that live in the same area and that are able to interbreed. Okay, if they don't live in the same area, they can't interbreed. The mice at my house can't interbreed with the mice at your house. They're too far away. They can't get there. Koketso's dog cannot get together with my dog to have babies. He lives far away from me. We're not going to get together to do it. All right. So a population is going to be individuals of different ages that belong to the same species, okay, that live in the same area, and because they live in the same area, they're able to interbreed. That's when, I mean, think about when we have geographical isolation, you've got this one population that is split into two populations. And then you end up with a new species that develops because that's part of speciation. So you must know what a population is. All right, now let's go to our question. And it says here, we're going to use natural selection. Okay, we're using natural selection to explain the higher percentage of black lizards in the population after the 30th generation. Now look here. Here we've got brown goes 80% and then 80%. And, well, okay, the red here make up the other 10. But by this 10th generation, the red guys are extinct. Okay, they did. They just didn't make it. The red color wasn't good, and we're going to say why now. The browns, well, we had 80 and then 10, and then 80 and then 20. And look here, the black steadily goes up and up and up. At this point, we have 70 and 30. But by the 30th generation, the black lizards are now more than the brown lizards, which means the black color is favorable. It is very favorable for the survival of these animals. All right, now go back to the top of the question, and it said we've got this mutation and that changes the body color. All right, and the black lizards are well camouflaged. They can warm up faster, which then gives them more energy to get away from predators. So how do we answer this question? And the format of any question that talks about natural selection is going to be the same. So let's do it with white. We're going to start off by saying, first thing, there is variation in skin color in the lizard population. Now remember, the formula for natural selection is there is variation, okay? Then, because of the environment, we have some traits that are, or characteristics that are going to be favorable and some that are not. So that's what our next step is. We're going to look at what is favorable and what is not. So we go back to the question, and the question said here, you've got your black and your red lizards, all right? The black lizards are well camouflaged, but look here. What do you think happened to the little red ones here? What happened to them? And I've just changed my color, which I forgot. What happened to the red ones? They died out. So we'll say the red lizards are poorly camouflaged. Camouflaged. Okay, because I mean red on a dark rock. What do you think? It's like a beacon. There's food. So the red lizards are poorly camouflaged, okay, and get eaten by predators. Okay, they die. Right, now we'll use a different color. The brown lizards, well, they carry on for a while, so they are better camouflaged. Okay, warm up faster. Than the red lizards, okay, and have energy to move faster to escape predators. So they're okay. They're doing all right. Your red ones, bad. They die. Your brown ones, well, some get caught, some make it through, and they pass on to the next generation. but our best of all is going to be the black lizards. Are well camouflaged. Okay, they are well camouflaged and they warm up the best and fastest. So have lots of energy to escape predators. So do you see what I've done? I've said the red ones, well, they didn't do too well. The brown ones, well, they're better than the red, and they have enough energy to sort of get away and escape from the predators better than the red ones did. But look here, the best guys of the lot are going to be the black lizards. They are well camouflaged. They warm up nicely, okay, and they have lots of energy to get away. So, the black, I mean, this is common sense. The black lizards survive the best out of the three, and reproduce. Okay, so they're going to reproduce. Why? Because they've survived. They survived the best, and they then reproduce. They pass the black skin color allele to their offspring, comma, which produce more black lizards in the following generations. Okay, so that's full marks for this question. I'm going to take orange. So this is what you have to say. There is variation, and then you must explain what the variation is. Okay? Then you go with the unfavorable characteristic or trait and the result. So what does it do? Well, it's simple. The red lizards, they're poorly camouflaged and they get eaten. Or the tortoises have a short neck, so they can't reach the food. Do you understand? Whatever that trait is. The snakes have a better marking on their bodies, and the predators are scared of them. Okay, so unfavorable, then that's your second point. Your third point is going to be your favorable, why something is favorable. So what the trait is that's favorable, and the result of that. Okay, so they can survive, they are well camouflaged, they move the fastest because they warm up so nicely, and they can escape their predators. So, which ones are the best? Therefore, those guys are the ones that survive, and if they survive, they reproduce. Okay, if they reproduce, they then pass that allele. Okay, they pass that allele on to the next generation, and that is the end of the question. But it's the same formula about any organism that they give you, that they're going to say, okay, well, how does natural selection work? There is variation. When you're sitting with an environmental situation, that is going to mean that the ones with a favorable trait survive and the others don't. That's natural selection. Okay, so, okay.